Welcome to my office, my electrical safety learning lab. Thought I'd do a quick post about detailed arc flash and shock equipment labels and sort of the evolution since my involvement back in NFPA 70 2004 and when I was working for large oil and gas here in Calgary, Alberta, Canada, trying to get a handle on getting arc flash hazard incident analysis studies done, and then the detailed label. So on the screen are some what I call compliant arc flash and shock equipment labels, compliant to ANSI Z535, compliant to NFPA 70E, and compliant to NFPA 70, the NEC. Now, there might be one debate with respect to the NEC with the inclusion of a maximum available short circuit current or fault current. Again, but that can be handled with a separate label, right? It could be added to this label, but the thing is, this label's already getting pretty busy. So we see a label for 125 volts DC, which would now change to 150 volts DC or greater than that as a nominal DC voltage. We've got a lighting panel at 28 volt on the right. Again, the danger signal pan, as per ANSI Z535, is used when the hazard and the risk is high risk. In this case, there is no arc flash PP available with an arc thermal performance value greater than 140.0 calories. So residual risk can be reduced to as low as reasonably practicable, which would be a 50% probability of a second-degree burn injury, right? Up to 140.0 calories. The plasma may be bigger than say a 12 cal or a 25 cal or a 40 cal. Stuck in my brain that 40 cal myth, 75 cal per centimeter squared incident energy from an abnormal arcing fault and arc flash. But from a risk assessment perspective, that's when we should have danger. All right. On the right-hand side is an MCC label. On the left-hand side is switchgear with a maintenance mode switch. And this is where I've been posting that we need the electric protective device in the footer. The qualified person needs to know the upstream protected device. And in this case, when they turn the mains mode switch on, it's altering the settings on that relay, right, from group A to group E and lowering the incident energy on the sub-fed electrical equipment from that circuit breaker. All right. On the right, arc flash relay on, right? So again, load side of a feeder breaker or load side of a main breaker. And these engineering safety by design items would be included on low and high voltage switchgear. All right. Again, another label, an example of a capacitor label with the new formulas in NFPA 70 published in 2024. Again, this could be a more detailed label. Now, IEEE 1584, just a quick comment. We've got 1584. Again, the formulas, we've got 1584.1, how to do an arc flash hazard incident energy analysis study. If you're not aware of it, you should get it. It doesn't cost a lot of money, 1584.1. 1584 is more expensive. And then just published last year is 1584.2, which is a guideline again for doing data collection for low voltage equipment less than 1,000 volts, in this case AC, or probably less than or equal to 1,500 volts DC. All right, so there's the key standards. Now, there's other formulas I've talked about, and I have a summary of formulas document I posted. Again, I'll probably post that again and also do a video on it. So this also changed in 70E, where again at a supervised location, you could actually issue the result sheets, right, from the actual calculations, and you pretty it up, put an Excel spreadsheet, I put a header and footer on it, rev control and the like, and then you could provide that as a secure PDF, or you could post it in electrical rooms and put this generic label on. Now, not a lot of companies are doing this. Some are, right? Some aren't. Now, I also have previously posted my arc flash and shock detailed electrical equipment um, infographic. All right, so we've got that, which talks about all the different information on there and gives you some of the examples. And something else I recommend, this is an 8.5 by 11, again, ANSI Z535 notice sign. When I've been in the field rolling out electrical safety programs, doing practical training in high and low voltage electrical rooms, again, arc resistant electrical equipment is becoming more common for high voltage and for low voltage. But I'm in there and the electricians haven't been trained on the new power system when it's a capital project. And for instance, a hospital's cutting over and they were not aware. So this would be put on again by the responsible electrical engineer or indicated to put this on. And then everybody knows that it is arc resistant electrical equipment. The same thing when there's maintenance mode switches or arc flash relays. Again, 8.5 by 11 notice sign is strategically placed on the electrical equipment. Not too many of them, and you'll see that coming up in my sticker shock pictures coming up. But this increases awareness of that these incident reduction methods are there, or that the electrical equipment is of an arc-resistant design, and that impacts again, through to our racking on arc-resistant electrical equipment doesn't require any arc flash PPE. Now, some bad labels. The one on the left, I think I got that maybe 15 years ago or so, and it's just insane, right? 11,952 calories and a 7 mile arc flash boundary. And this was installed on electrical equipment. This is where we're having an issue with credibility, and it's getting better, but this whole thing with the 40 cal myth is still a problem. I created this label. I didn't take a picture of it where I had green, warning on green. Well, as per ANSI Z535, warning needs to be on orange. This is what I call sticker shock. You know, just panic. I arrived, and I'm telling the client when I do an external electrical safety audit, what's going on here. Like this is panic mode, right? Putting a label on every MC starter bucket or, every MC starter bucket plus the detailed label. On the left, there was no detailed label. They hadn't completed our flash hazard incident analysis study. This one has a detailed label on every MCC bucket. This is just confusing for the qualified person. To me, it just lacks, competence and understanding, what we're trying to do here, right? We have the cable incoming section or the main breaker section. We have a load and line side label. And if it's a long MCC lineup, we have the load side, label at 5 sections, every 5 sections, so that's visible, right? This is a problem, a huge problem, and it's probably global. I know it's global, right? And another one, 25,330.1, right? Calories per centimeter squared, a 1,293 foot arc flash boundary. This just, on a site that's installed, the qualified persons are just going to wave their hands up in the air, and it starts to lose a lot of credibility and impacts what we're trying to do, which is change the electrical safety culture, get the workers to be confident, right? And get them to again follow their company's electrical safety program, fill out an energized electrical job safety planning form, pre-inspect it, check it, and truly take ownership that the residual risk level is as low as reasonably practicable. Another one with labels on every door and up so high you can't read it, especially like me with my readers, right? And other labels where the categories were listed, PP category. There was never, ever a technical correlation between an arc flash PP category and incident energy. This was exacerbated by the power system software vendors putting a default column in that listed the categories, just like they put the default column in that if the incident energy was greater than 40 calories, it said dangerous PP note, PP doesn't exist. Again, the employer does the risk assessment, not software, not the engineer doing the incident energy analysis studies. Again, hazardous category D, danger label at like zero point 0.1 calories. Again, these are all just sort of issues that I've seen out there, unfortunately, right? And ultimately, just this last slide and bring this to a close is two arc-rated clothing levels. I actually standardized on this probably 15 years ago, and this was clarified in NFPA 70 finally. Again, so we got to get this right. One of the other issues I've seen is, 2 decimal points or 3 decimal points, on the incident energy. It should be a single decimal point because the ATPV of this arc flash PP behind me is only a single decimal point. Again, as an electrical engineer, you got to get this right. I know that literally hundreds of thousands of these reports have done globally, and I'm claiming and telling you that there's errors and omissions and misinformation that need to be backed out and communicated to industry, and that's part of my mission as we continue to work through this and we work to get this right out there. Any questions, get back to me. More videos coming. Have a great day. Be safe.